Okay, hi everyone. Thanks for attending today's webinar. So the title of today's webinar is Running Large-Scale Regional Hazard and Loss Simulations. My name is Wael Elhaddad and I'm a postdoctoral researcher. I work for the SimCenter and I'm based at University of California, Berkeley. So before I start my webinar, I'd like to give a quick disclaimer. Today's webinar is coordinated by the Natural Hazards Engineering Research Infrastructures Computational Modeling and Simulation Center, also known as the SimCenter. This webinar is supported by the National Science Foundation under awards number 1612843 and 1520817. Any statements in this webinar are those of the presenter and do not necessarily represent the views of the National Science Foundation. So let me begin the webinar by giving a quick outline. So in the beginning, I'll actually have a quick introduction about the NHERI SimCenter research tools in general. Then I will talk about the regional simulation tools, or what we now call RWAIL. So I'll do a quick review of the previous webinar about these tools and maybe talk a little bit about some of the new features. Then I will talk just briefly about a testbed that we are developing that we use to kind of demonstrate how to use these regional simulation tools. So I'll talk about Anchorage Testbed in particular. I'll talk a little bit about the buildings data, some of the recorded ground motions. And at the end, I will give some demos. And these demos will be to run some of these simulations on your local computer, or run the simulations, run kind of a large-scale simulation on high-performance computers. And at the end, we'll have some time for questions and discussion. Hopefully, the webinar will be less than 1 hour, so we'll have enough time for a lot of discussions and questions. And yeah, that will be the end of this webinar. So in the beginning, I would like just to give a kind of a quick introduction about research tools that the SimCenter develops. So the SimCenter actually develops what I call cloud-enabled research tools. And the reason I call them cloud-enabled research tools and not cloud-based research tools is because these tools actually can run locally, and they can also run on the cloud or on high-performance computers. So they can run without the cloud and they can run with the cloud. So they run in both modes. And these tools are scalable to run very high, very large-scale simulations on the high-performance computer. Many of the tools, as you might figure out from the names here, they have emphasis on UQ. So all of these tools have some sort of features to define and propagate uncertainty in your analysis. The SimCenter also provide educational resources, and that comes in the form of webinars. It also comes in the form of our research tools training and the programming bootcamp that we have annually, and others too. So what I wanted to talk about today is a little bit kind of the relationship between the SimCenter and DesignSafe, because this can be confusing for many people. How is the SimCenter different from DesignSafe? A lot of times when you use the SimCenter tools, you actually have to use also DesignSafe tools. So there is actually a close relationship, but these two facilities are actually separate facilities. DesignSafe provides data storage. It also provides you access to HPC resources, and it also provides you some access to many cloud deployed applications. So you can run your, for example, OpenSeas model or your OpenFlow model online through the DesignSafe Workspace. And you can also store all your data, your inputs and outputs there. The SimCenter have developed many research tools like UQFEM, PPE, EUQ, and CWE. And all of these tools, they can work locally, but if you want to scale them and run very large simulations, they can take advantage of an application framework that the SimCenter has developed. and it has been deployed into DesignSafe. It's sort of the back end of for many of our research tools. And this application framework is what I'll be talking about a little bit today. And we've talked about this in one of the previous seminars, and it will probably come up in many of the upcoming webinars about the different research tools. But what I want to mention is that many of our research tools, they share one component, and this is the application framework. And this framework is designed in a way to make it flexible that it can support different applications. So for instance, EEUQ can use this application framework in one way or configure it in a certain way. And the PPE tool would use the same framework and configure it in a different way. So there is one shared component which we call the application framework, and this is what I'll be talking about mostly today. What I want to show you guys today, and hopefully by the end of this webinar, you will be able to get direct access to this application framework and be able to use it to do a large scale simulation. So let me talk about this application framework in a little bit of detail. So this application framework basically breaks down simulations into different pieces. One piece can be the description of your assets, description of your buildings, things like your building information model. Another piece is the hazard description. How do you characterize your hazard, whether it's an earthquake or a hurricane or others? And then there is a piece for modeling, response estimation, and damage and loss estimation. And in all of these pieces, they have some database that support them. For instance, when you're doing loss estimation, you might need a database of fragility functions that you can get access to. And also all of these tools are capable of supporting uncertainty propagation. So in many of these tools, we allow them to define some uncertainty in the models, and we allow them to also propagate this uncertainty. Just to give you guys a quick example, one of the tools we have is UQFEM. So in these tools, we basically have the modeling piece and the response estimation piece. So these two pieces only, in addition to the supporting databases and uncertainty quantification, would represent UQFEM. And that basically allows you to get a model, a finite element model, and start defining some random variables and doing a Monte Carlo simulation with it. So that's what UQFEM does. It takes a finite element model and introduces uncertainty in it. Another tool that we have is EEUQ, for instance, which takes this a little bit further, where you have an asset description, you have an hazard description, and the tool takes care of defining some of the uncertainty for you, and also defining the hazard input on your, let's say, building. So in this tool, you would define a building model, you will define the earthquake characteristics, and then you can do things like hazard analysis, or you can generate you can use stochastic models to generate loads on the buildings that are uncertain, and then you can do the response estimation after that. So that's, hopefully can convince you that many of the tools we have already are already using this application framework. And one thing I want to point out again is that this can run on your local computer, but it also can run on the cloud. And we will get to the point where we run it on the cloud today. And hopefully maybe even some of you guys can follow this demo and run their own simulations today too. So when I talk about running on the cloud, it means running through DesignSafe, and at this point running on resources that you have access to using DesignSafe. But there are actually ways to even run this on other cloud resources. Let's say you have access to Amazon AWS resources, you have a compute cluster that you want to use. There are ways to kind of customize these tools to make them run on these resources too. But we will not get into that for today. But if someone is interested, we definitely can talk about this or follow up about this later. Another thing that I would mention is that even though now this can directly work on the computing resources that's provided to you by DesignSafe, you can also run it on your own HP resources in your own institution. So let's say you have a big allocation in your institution and you want to run this simulation there, that's also possible. So what we want to do today is we want to do a regional simulation. So these are the tools that I'm going to talk about today. And by regional simulation, I mean that we start from a region that has a large number of buildings. So we start from the building inventory. We have some hazard description. So for instance, this is the Bay Area. This is San Francisco, subjected to a magnitude 7 earthquake on the Hayward Fault. And we want to find out what are the hazard consequences. And in this case, what I'm visualizing here is basically the loss ratios for each building in San Francisco. And it's what I wanted to emphasize here is that this data can be as fine-grained as possible, but you can also aggregate it on for like larger regions or whatever if you want to. And this is very easy to do in GIS tools. We'll maybe talk about this a little bit later. But the data itself, you can obtain them on a very fine level, on a parcel level, I would say. So you can find for each, you can basically do simulation for each building in the region with these tools. So one of the things I'll show later today is how to access some of these tools on the DesignSafe workspace. So what you guys see here is actually accessing one of these tools on DesignSafe workspace and specifying the inputs, things like the data used for the regional simulation, a configuration file that specifies which applications or what models are being used and so on, and some other parameters that are important for the input, like the number of buildings to run the simulation for. One thing that's important to point out is when we're running all of these tools, the input is expected to be in the DesignSafe data depot. So for instance, here I was trying to run a simulation for San Francisco Bay Area, and I had a data file that was a large data file. It was 1.2 gigabyte. And that file, I had already spent time uploading it to the data depot. But once the file is there, once your input is in the cloud, you can start invoking some of these tools on that input. So I had a data file and a configuration file in the data depot. Then I ran the simulation and I could get basically a flat file that looks like this, which has for every single building in this region, the median repair cost, the downtime, whether or not this building is red tagged, the loss ratio, and the location of the building. And this location, as we will show later, it will turn out to be very handy because once you import this file in GIS tools, you can kind of have the spatial distribution of all of these results, because each one of these points has a location. Then you can start doing spatial joins, and you can take this data and join it to other layers of data you have, like the building footprints or the parcels. And we'll see this in the demo in a little bit. So one thing I want to point out too is you really have access to a lot of computational resources here. And just to give you guys an example, I wanted to run a large simulation for the Bay Area with 500,000 buildings. So for this simulation, I actually requested 64 nodes, and each one of these nodes have 64 processors. The total number of processors was around 4,000. And basically what this means is that we can analyze 4,000 buildings in parallel. You can think of it like that. We basically try to parallelize the process of the computations, and because we have so many processors, we can run many of these buildings in parallel, and that basically reduces our computation time. So for this particular simulation, it took just a few hours. So one of the other things I'll show you guys today is how to run similar simulations, but you run it locally on your local computer. You can run this on your laptop or desktop. So we are already releasing some applications, some sample data and examples for you guys to use. And I'll actually demo running some of these today for Anchorage. And basically the way it runs locally is it runs as a console application. On HPC, it also runs as a console application. So what this means is that you run your program from the command line. You basically give it some input files and some input data, and you expect to get some output files. So in the demo later, I'll show you guys what kind of inputs and outputs you get. But you can think of this in one way is that you provide this simulation tools, some building description, some hazard description, and your output will be the damage and loss calculations, or the damage and loss results for this set of buildings. So it will be the repair costs, the downtime, the red tag probability, and so on. One of the things that's important to point out is the framework we have relies on having standard interfaces between different buildings. So for each category, whether you're modeling your building, you're modeling your hazard, or you're creating a structure analysis model, or even doing loss assessment, we have different applications, different tools, I would say. And each one of these tools might be using a different method or a different assumptions. But all of them would expect to have the input in the same format and the output in the same format. For instance, some of these modeling tools would internally use OpenSeas, but the input will not be OpenSea's input file. In this case, the input will be a standard interface file. We call it the SAM file, the structure analysis model. And the tool that we have will take this file and convert it to an OpenSea's model. And the output also will not be OpenSea's output, but it would rather be a standard file, which is the EDP file in this case. So because of that, we can take different pieces and feed them together and create different kind of workflows for our analysis. So just to give you guys an example, if you're doing an earthquake, we can use a very generic building information model. We can maybe use seismic hazard analysis to characterize the hazard and use a simple, shear building model to model the building, and maybe use something like HAZES for loss assessment. Or maybe we have a higher fidelity model where we have a detailed building information model, and maybe we use a more robust way of characterizing the ground motion at the building site. And we have a high fidelity finite element model that we use to evaluate the ETBs, and then we use FEMA P58 for loss assessment. So you can configure these tools to do different things. You can configure them in a low fidelity, a high fidelity, or even multiple fidelity level modes. So you can have a region, and for some buildings, you're creating low fidelity models. For other buildings that are more important, you can actually create high fidelity models, detailed models, I would say, for these buildings. So just to talk a little bit more about this, one thing that we have for these tools is actually a configuration file. And this configuration file is written in JSON. And like you guys have seen in the previous slides, we have just different sets of computation, like the building information model, the event, the structure modeling, the EDPs, the simulation. And for each one of these, in this JSON file, we basically specify some configuration. So you can specify where your building data is coming from, how is your event characterized, how do you model the structure, how do you evaluate the ETPs, how do you do simulation, and how do you handle the uncertainty, and how do you do the damage and loss calculations. So just to give you an example, one of these is, let's say, the events. In this case, we have an application that we call NL-SW4, which basically uses outputs from an SW4 simulation of an earthquake. And it basically needs the data that it needs to use is basically the simulated ground motion. So it takes the path of the folder that contains the simulated ground motions. In this case, it was a simulation for a 7.0 earthquake on a Hayward fault. Another example is for damage and loss calculations. We can use an implementation of FEMA P58. This particular one was actually provided by one of the by a research group in China, by Professor Jinjing Liu and his research group, and they provided an implementation of FEMA P58, and they basically contributed this part to the SimCenter tools. And this is one thing I want to point out here, is that we try to build this framework so that we can take existing application and start using it inside this framework. So many of the pieces that we have been using are pieces that researchers have contributed, and also these tools in general are very open. Everything is open source, so we are very open to receive contributions from the community. So if you have models, if you have applications that create certain type of models or do loss calculations or others, or fragility functions, all of this can be contributed. And we are actually working on some new features to create citations for all the models and data that are being used in the simulation, so that when someone runs a regional simulation, they get a list of citations of what they need to cite given the different models they have used and the different data products they have used. So just to follow up on this example, we were talking about damage and loss here, and for this particular case, some of the data you might need to use is the ATC curves, basically the fragility functions and sequence functions from ATC. So before I actually start showing you guys the demo, I wanted to talk very briefly about the Anchorage earthquake testbed. So this is actually a testbed we've been developing. We mostly worked on this in December and sometime in January. And basically, we wanted to do a simulation of the earthquake that happened in Anchorage, Alaska on November 30th. It was a magnitude 7 earthquake. And you guys can see here, this is downtown Anchorage and the location of the earthquake. There is another community a little bit to the north. It's called Eagle River. So in this testbed, we included 12,000 buildings in that community too in the simulation. And we basically obtained most of the data we have about the buildings from the tax records. So from the tax appraiser records, there was 97,000 records, and we have processed this, and we were able to get information for 84,000 buildings. Most of these are residential buildings. And for the earthquake, just to characterize the earthquake in this case, we used some of the recorded ground motions that are available through the Strong Motion Center. One thing I want to point out here, in the SimCenter, the SimCenter is a software development facility. So we basically kind of experiment with software development. So we develop software tools for researchers to use in the research, but we don't necessarily actively engage in the research, meaning that we are not trying to come up with the right answer for Anchorage, how many buildings will be damaged or the amount of damage or so on. But we are trying to develop the tools that researchers can use to do that. So what we are showing you here is just very maybe preliminary data for the buildings and the ground motions, just to demonstrate how our tools work together. And it's not meant to be a real simulation or an accurate simulation necessarily for this particular earthquake. But what I'm gonna show you guys how we ran this simulation. So what we did is we basically, just to characterize the shaking at each building, we basically pick up the nearest recorded ground motion and use it for the analysis of the building. And when we did this simulation, we were able to obtain the damage estimates for each building out of these 84,000. And the results shows around 3,800 red tagged buildings and 14.5 net buildings loss ratio, which is a little bit high. But again, this is an opportunity for the community to maybe pick up this simulation and do research about it and improve on how to characterize the ground motions, how to maybe get accurate building informations, and how to do the loss assessment maybe more properly. But again, what I'm going to show you guys today is how to run this simulation in its current form using these preliminary data products, and how to come at the point where you have the loss ratios for every parcel in this region. So I think now it's the time for the demos. So let me exit this presentation and go to Okay, so the first thing I want to show you guys is how do we run this simulation locally? How do we, let's assume that we have some information about the buildings, some data about the buildings and the ground motions. How do we run this locally? So the way that our tools run is through a configuration file. So I have a configuration file here. It's called Anchorage m7.0.json. So I'm going to show you what's inside this file now. So in this file, you basically have the different programs that we will use and the data that we will use it with these programs. So for instance, for the building information modeling, we use a generic BIM model. So we're calling a program called generic BIM database, and it takes a building file. It's just a flat file. So this Anchorage buildings.csv, which comes from this data folder. So let me quickly show you guys where this file is. So there is a data folder here, and inside this folder, there is a flat file, this Anchorage buildings.csv. So I'm going to open this. And this file basically has, for each building, it has information about the area, the total area in square foot of the building, the number of stories, the year this building was built, and the occupancy type, the latitude, the longitude, and also the parcel ID. So, and you can see that this was again obtained from the tax records, but we have this for 84,000 buildings. So this is what we're starting from. So we have spent some time looking at the tax records, and we compiled this database from it. And this file is actually available on the in the DesignSafe community folder, and I will show you later in this webinar how to get access to this file. So this is one of our inputs. So going back to the configuration, so we specified which application we will use and which input file we will use. So we're going to use a file that has the building information for Anchorage in this case. Now for the event, in this case, as I mentioned, we just wanted to come up with a simple method to characterize the ground motion, just to demonstrate to you guys how to do this regional simulation. But of course, there are much better ways to characterize the ground motion than what we are showing you now. But this particular case, the application we're using for the ground motion is called NNGM, which stands for Nearest Neighbor Ground Motion. In other words, this application will look into a list of ground motion records and will select the nearest one. And you can see that this application takes two inputs. It takes a folder. It takes a file that defines the ground motion, a JSON file, and it takes a folder that has the records. So again, let me show you this this file and this folder again in the data folder just quickly. So if we go to the data folder, you see there is a JSON file. I'll open this. This file has, for each station, it has the ID and the record files and the location of this recorded ground motion. And then there is a folder that actually contains these recorded ground motions. So over here, there is 12 records, there is 24 files. This is because in each station we have 2 horizontal components. So each file has basically the record, and some of these records are in different formats. There are 2 different formats here. One is called Cosmos and one is called SMC. These are formats that were developed by USGS, and because we just obtained this data from the Strong Motion Center, we wanted to keep it in the same format. So we got these records from the Strong Motion Center and we are using them as they are. The only thing we needed is to basically have them, all of them, in a single folder, and we started using them with this application, NNGM. So as long as we have these records, this application will be able to search for each building. It will search for the nearest record and it will use it as the ground motion input. Now for the modeling, in this case, we are using MDF-Flu. This application uses a stick model, shear building model, and some of the data is based on HAZAS. So it used some of the data from HAZAS to come up with an equivalent multi-degree of freedom shear building model. And we're using standard earthquake EDPs, the floor accelerations and story drifts. We're using OpenSeas for the simulation and Dakota for uncertainty quantification. And for loss assessment, we're using the FEMA P58 implementation that was provided by Professor Liu. So this is the configuration file. And as I said, this configuration file makes use of data available in this file, Anchorage buildings.csv, and the ground motions, as I showed earlier. So what I'm going to do is, right now I'm in this folder, and I'll start running the command to run this simulation locally. In this folder, you have applications, you have data, and you have this regional earthquake simulation.py. This is the Python script that invoked the simulation. So I'm gonna run So I'm running this regional earthquake simulation, and I'm giving it the configuration file for Anchorage. This is the file that we looked at. And this will start the simulation. So it should take just a little bit to, I actually configured this file to do just 3 buildings, just to show you guys we can do 3 buildings locally. But you can do, of course, more. I wanted to quickly be able to show you guys some of the results. So it's running the simulation for the first building. And we can start looking at some of the files. So what it generated a BIM file, SAM file, event file, EDPs. And once it finishes the loss calculation, it will also generate a damage and loss file. But let me show you guys what's inside some of these. This is the building information model for one of these buildings. This was a residential building. It was built in 1959, 2 stories. This is the area, the replacement cost, and the location of the building. And the height was assumed to be a random variable in this case. And the tools takes care of propagating this random variable. And as I said, it generates the structure analysis model, the event, and the EDPs, and at the end it gives you the damage and loss. So let me look at this quickly. In this case, the median loss ratio for that building was 14%. The repair cost was 79,000, and the retake probability was 29%. So it will do this for each of the 3 buildings that are specified in the input file, and then generate a summary of the results. So for the 3 buildings, you will get a summary. For each building, you will see the repair cost, the downtime, whether or not this building is red tagged, and the loss ratio, and also the location. So it's kind of a flat file. It's a CSV file that has these results. And this is suitable, running locally is suitable for developing this kind of workflow and configurations and testing it, and also may be suitable for running a small number of buildings, maybe, I don't know, maybe 100, a couple of hundred or something. But once you want to run this on a very large scale, that's when you need to go to the cloud or HPC and run these tools. So what I'm going to show you guys right now is how do we run this on a much larger scale. So before we start this simulation on the cloud, we actually need to get our data on DesignSafe Data Depot. But we have already uploaded some of these files. So if you guys go to the data depot and then go to community data and go to SimCenter datasets, you'll find a folder called Anchorage M7. And in this folder, let me open it, you'll find 3 files. The building files that we talked about earlier, the ground motion file, and the configuration files. These are the same 3 files that we used for the local simulation. So the building files, ground motions, and the JSON. And you notice now that this building file and ground motion files are compressed. They are in zip format. And we do this because sometimes for running this simulation, these files can get really big. So it's more efficient to maybe transfer them in a compressed format. But it's also possible to run without the compressed format. So if you guys want to run this simulation on your machines, what you can do is you can go to these datasets. You can select this folder by clicking on this row. You can click on copy, and basically it will list all the folders you have in your home directory. It's called My Data, and at the bottom there is copy to, and then it will be your username. In this case, it's copying to my data folder. I will not click on copy now because I've already done that. So let me show you guys what I have. If I go to my data, so this is my home folder. There is already a folder called Anchorage M7. It has the 3 files. Now, these are the same files that we used to run locally for inputs. So what I'm going to show you guys now is how to use the tools that we have deployed in DesignSafe to run the same simulation. So now if you go to the workspace, basically you can go to the workspace by clicking on Research Workbench and then clicking on Workspace. And you can click on Simulation and then click on RWhale. RWhale is the same regional tools that we have. This is the name we selected for the application. It stands for Regional Workflow for Hazard and Loss Estimation. And you can click on that and it will open this view for you. So it will tell you you can now run RWhale, and it will start giving you some information about the inputs and the parameters you need to pass and so on. So as I mentioned, I have already copied this input folder from community data to my data. So what I want to do, I want to start selecting my input files and add them to this computational job and start it. So I'll start with the buildings. So I'll just grab this building file and add it as one of the regional simulation data because we need all the buildings data to be able to do the simulation. And then it mentions here in the help that you can have 1 or more files for the regional simulation in compressed form, and that these files will be extracted inside the data folder. The same way we've seen it when running locally. You have a data folder and you have your buildings information and your hazard characterization data in there. So what I'm going to do is I want to add also these ground motions. I separated them into 2 files. I could have just selected 1 file for both of them, but I've separated them into 2 files to be able to show you guys that this is also possible. So I'll click on add, and then I will drag this ground motion file and use it as an input for the regional simulation data. And then it asks for the configuration file. This is the same file, the same JSON file we talked about earlier that specifies which programs you're going to run and which steps you will have in your workflow for creating the building information model, characterizing the hazard, and so on. And finally, you can specify the number of buildings. I'll just select 1,000 now. Hopefully, maybe by the end of this webinar, we'll see this job has ended, but you can select more up to the 84,000, the total number of buildings. I'll turn on logging, which I just want to show you guys that we can also use logging. This is a useful feature for troubleshooting if something goes wrong. You can look at the logs and see what went wrong. And in this case, I know this only takes 10 minutes. I'll just select maybe 1 hour. It's not a good idea to select a large runtime because if you're requesting resources for a long time, you might have to wait longer to be able to access these resources. So maybe instead of 1 hour, I'll just make it 30 minutes. And I'll give this job a name. I'll call it Anchorage M7 demo. Oops. And I'll select the number of nodes. Now, one thing I want to point out is the nodes. These nodes are computational nodes on the Stampede 2 supercomputer. So each one of these nodes has 64 cores. So selecting 2 nodes means we will have 128 cores. In other words, we'll be running simulations for 128 buildings in parallel. So I think this is suitable for running these 1,000 buildings in about 10 minutes or so. So I'm gonna start this job and hopefully this succeeds. Sometimes it would not work if I left this web page without activity for some time because it will maybe log me out from this session. But now it says submitting the job, so we'll see what happens. And once this job starts, I will go and find a previous job where I ran a large number of buildings and show you guys what happened. Okay, so now it said job submitted successfully. But this is the job we named it Anchorage M7 demo. It has been submitted and you can monitor its status on the right. So if you go to this job status on the right-hand side, you can monitor the job. You can refresh it also and see what's happening. It says processing input now. It seems like the job started processing. Just to show you guys what happens next is once your job is finished, this is one of the previous jobs that I ran. It had 84,000 buildings and it took, a few hours. I'm gonna go and see the output of this job. Okay, so the output you get is this CSV file, which contains the damage and loss. There's also this log file, as I mentioned, you can use this for troubleshooting. But let's look at the results. Okay, it's maybe a large file. It has 84,000 buildings, so it takes a few seconds to load. But basically what you will see, it's the same flat file we showed earlier when you run locally, where for each building you have your repair cost, you have your downtime and so on. So as you can see here, median repair cost, downtime, whether or not this building is red tag, loss ratio, latitude and longitude. And this is actually a huge flat file that has, tens of thousands of buildings. So I've already ran this for all the buildings in Anchorage. And once you have this file, you can start doing interesting things like using this in GIS tools. So I'm going to show you guys quickly what we can do with this. So in GIS, we have these parcels for Anchorage, and I also have the building footprints over here. And what I did is I started importing some of these results. You can see that these results are actually spatially located on the right location for each building. And because of that, you can start doing some spatial joins, and you can use a lot of the existing tools in GIS to come up with very nice ways to visualize this data. So what I'm going to show you guys is actually the loss ratios over here. These are loss ratios color-coded on the parcel level. So for each parcel, it has a color that shows, so the yellow colors are smaller loss ratios, the red colors are higher loss ratios. You can also show the red tags. And yeah, there are many other tools in GIS that you can use. For example, you can take all of these results and aggregate them over areas or blocks if you want, or something like that. So you can, the results, as you guys can see, let me show you one of these files that we have imported here. The results are very fine-grained. They are parcel level damage and loss estimates, but you can aggregate them on larger areas if that's needed. And you guys can see that one of these layers basically that we imported here is nothing more than this flat file we have seen earlier in the DesignSafe data typo as output from this computational job. So you can take your output from there, you can download it and start visualizing it right away. So yeah, I think that basically concludes this webinar, but you guys feel free to try to run the same simulation. And of course, I mean, we're always looking for contributions from the community. Maybe someone is interested in looking into better ways of characterizing the ground motions or coming up with a better way to do the loss assessment or to improve the building inventory. I don't think we have all the buildings in Anchorage because the data we have is based on tax records. So any building that's tax exempt, for instance, we may not have it because the tax records will not have enough information about those buildings. And yeah, I think I'd like to open the floor for questions, and I don't know if anyone has already asked questions or.
Yeah, well, thank you, Wael, for this presentation. It was very informative. So at this time, we'll start the Q&A session. There are a few questions that have already been sent in via the chat window. And remind people, if you have a question, you can either raise your hand, which is one of the buttons in the Zoom meeting window, or you can relay the questions via the chat to the moderator. Well, the first question is, if I run into a problem trying to replicate the demo, where do I go for help?
Yeah, so that's actually a very good question. And I think I personally prefer that many of the correspondence happen in Slack. And the reason this is important is because many of the issues that someone will run into, it will probably happen with other people as well. So this is a very nice way for us to all like kind of have a discussion that's open, everyone can see. And if you guys go to if you guys have Slack already installed, you can go to the DesignSafe Slack workspace, and there is a channel called SimCenter EQ_workflow. There's already some discussion over there. You'll see that some students had started using these tools. They had difficulty. We had few bugs that we were able to fix for them, and they helped us, fix these bugs too. So I think this is the best place would be, I would say, the Slack channel, but you're more than welcome to just directly email us. You can email me or email the SimCenter. Let me show the website of the SimCenter, because over there is actually links. So I think it's in Join the Community. There is a link to the Slack workspace. And there are also contact informations, I think, if you want to collaborate or you have questions. Matt, Matt, maybe you can know better about.
Yeah, I think the Slack channel is probably the appropriate place. If there's a bug issue, then that you need to submit that as a ticket, and tickets are submitted at the main DesignSafe website.
Yeah.
And in order to join the Slack discussion, that's also administered by DesignSafe. So you would obtain access to the Slack channel through DesignSafe, which should be activated once you've created your DesignSafe account.
Yeah, and it's also, they can get to it from this link, right? I think if you click on this link, you go to the Slack Slack collaboration webpage, and this is the DesignSafe workspace on Slack. So there's information here about how to join the workspace. But once you join the workspace, you can actually go to channels and search for SimCenter-EQ_workflow. So if someone is having difficulty joining this channel, then definitely contact us. But yeah, we would definitely help you get on this channel. But you can also, I mean, I've had few students who contacted me by email, and that's also fine. I think in general, it's more efficient and more productive to have all our discussion in this central location where it's shared by everyone. And so it helps everyone else.
Okay, so another question is, I'm analyzing a particular building in your test bed. Can I add my model for this structure, or do you only support OpenCs in the MDOF model?
Yeah, so it's possible to have other models, and we are actually working on higher fidelity models. We started working, there's one of the other postdocs here in the SimCenter who started working on developing models for concrete shear walls. And we are actually planning this year to release some tools. We call it the expert modeling system. These tools are supposed to help produce good models or reasonable models for different types of structural systems. But it is also possible to bring your own codes and start using them inside these regional tools. So that's possible. If you look at the documentation, it explains how all these pieces are being put together. So it's possible to take one of these pieces, make a copy of it, and then start modifying it so that it uses your own model. But right now, what we have showed today in this simulation, or if you run these input files on DesignSafe, the model that you will be using is what we call MDOF-LU. And this is the shear building model that Professor Lu developed, or his research group. Professor Lu also mentioned he is going to contribute another model that's more suitable for taller buildings. So that should be upcoming in the next few releases. I think starting from now, hopefully we will have more frequent releases of these tools. So each time someone contributes a new tool or a new model or some new data, we will probably have a new release with a new version. For today's talk, I think one of the most important things we wanted to show is that these tools now can also be accessible through the DesignSafe workspace. Actually, in the SimCenter plan, I think for next year, we will start working on another tool. It's called RDT, Resiliency Decision Tool, and this tool will rely on this regional simulation. So we will have sort of a front end for all of these tools, but for now, as you guys have seen, this is accessible through the workspace if you want to do a large scale simulation. Yeah.
Okay. In the beginning, you showed a test bed for San Francisco. Are these results available too?
Yes, this is, okay, so the results from this test bed are available for the whole Bay Area. The input files at this point are not available because we don't have, I think, permission to share them yet. But we are planning to release at least the data for San Francisco City because this is actually public. So maybe we'll have this data available in one of the next two releases. Maybe I would say sometime in March or April, we'll have very similar to what we have seen today for Anchorage, something similar for just the San Francisco City. But both the data for all the buildings in the whole Bay Area and also the ground motion simulations, we don't have permission to share them or redistribute them, but we can help you actually get access to this data because the researchers who worked on this, they would be interested to collaborate with other researchers. So it's possible to get access to this data. For instance, for the building's data, you will need to maybe contribute with UrbanSim to get this data. Collaborate with UrbanSim. And for the ground motion simulation data, this data is available upon request. So you will need to contact the researchers who actually did this simulation for the Bay Area. And that's Dr. Arthur Rogers in the Lawrence Berkeley lab, I think.
as a follow-up question, I saw one comparison of results for that Hayward simulation versus HAZUS that included the red tagged buildings. I'm not sure if this is an apples and oranges comparison, but how would you summarize the main differences between HAZUS for earthquakes and this regional workflow?
Yeah, that's a good question. I agree that this is comparing apples to oranges. It's two different ways of doing the loss calculations, and even the response calculation is also different, although the model used to evaluate the response is in part based on HAZUS data. But the thing is, I mean, if you would like to say what is the biggest difference between these two is, I think the biggest difference is the granularity of the results. So the results we have are done in a way where you actually do the all the calculations for every single building, whereas in HAZUS it's a little bit different. So the results we have are very fine-grained. The results you get from the regional tools that the SimCenter developed is very fine-grained compared to HAZUS. So you have the freedom to take these results and aggregate them over, you know, census block areas or census tract areas, or even on the city boundaries or county or something like that. But the results themselves are very fine-grained. They are at the parcel and building level. Or at least the tools is capable of doing that. I hope this is what we were able to demonstrate. So this, I would say, the biggest main difference. Other differences might be in the methodology used for losses. For instance, it's FEMA P58 compared to HAZUS. So it has, you have to basically have auto-populate your building model with components, and you have to start creating realizations for different quantities of these components in the building. And it's more detailed process to calculate the losses.
Okay, and the next question comes from a participant directly. Ali Reza, are you there?
Yeah. Thanks for your nice presentation. My question is that are the OpenSys finite element models the same as the real building properties, like real cross-section for beams and columns or bracing systems? More exactly, I wanted to know to what extent are your OpenSys finite element models exact, and this is not as clear for me.
Yeah. No, I agree. I haven't actually elaborated much on the model itself, because we had a previous webinar about this application framework, and we talked a little bit about the model. But the model we use is what we call MDOF-LU. So it's a multi-degree freedom model. It doesn't. You can consider. Some people would consider it a low fidelity model. Others would consider it maybe a higher fidelity model. It depends on how you look at it. But it definitely doesn't take the exact like dimensions of all like columns, and like we don't even have access to this data, right? I mean, if you think about a region, if you're trying to do a regional simulation, I mean, it means like you have, let's say, like blueprints or very detailed building information models for the whole region. And that would, I mean, it is possible if we have access to this data to come up with more detailed models. But for this case, these models are based on certain assumptions on some data coming from HAZUS. Just to give you an example, some of the assumptions that goes into this model is that the building is a square and kind of uniform in X and Y directions. So the stiffness in X and Y is the same. And also all the floors have the same properties. So the same stiffness, the same mass. So there are certain assumptions that comes into that. And the stiffness evaluation and the damping evaluation are actually based on the capacity curves coming from HAZUS. And HAZUS can create a capacity curve for any building in a generic form based on just the basically the height of the building and the area of the building and so on. And the way it's done is it's based on the design code, the design code forces, basically. Yeah. So it's the model is still based on Hazes to some extent. The only difference between this and using a capacity curve in Hazes is that this model is expanded to be a multi-degree of freedom, so it will give you response at different floors.
Yeah, of course, it is a very clever solution for this high number of buildings you're analyzing. Thanks for your answer. Thank you so much.
Yeah, sure. One thing I want to also point out is in the documentation for the workflow, you will find a couple of references for papers by Professor Lu and his group in China, and one of these is actually talks in a little bit more detail about that particular model, and they also did some comparison to validate it and stuff like that. So if you want to find more information about this model, I would definitely refer you to that paper.
Another question, or one comment one of the participants had is about a station in Anchorage, number 8047, that had a misleading or incorrect factor. Do you want to speak to that?
Yeah. So we showed it in the screenshot, but we really didn't use it. What happened is we started working on this actually right away after the earthquake. We started working on this, I think, on 4th of December. And we did our first regional simulation on the 18th. And for that simulation, we were actually using 13 records. One of these records had a PGA of 0.8 G. And then what happened is on the 19th of December, this record was actually removed from the website. We haven't really followed up to know what happened with this record, but it seemed to be something that wasn't yet maybe trusted or something. So we ended up doing the simulation without this particular record. I think the question is particularly about this record with 0.8 G, right? Yeah.
Yeah. Well, I think we're a little over our 1 hour time allotment. But Wael, I want to thank you again for the presentation and sharing this with the community. To the participants, thank you for your questions and for your time. Please look to the SimCenter website for other upcoming webinars that we're scheduling shortly. Look for ways to join the community on that webpage as well. And hopefully we'll see you back here for the next webinar. Thank you very much.